Hi everyone. So in this video I'm going to just work through the review kind of as a uh, solution key. This is the in-class review version from the binder. So problem 1 and 2, complete the square to put the function in vertex form. So I'm going to first factor out the 2 in this problem to get x squared plus 6x. I kick over the 10. And then I know I take my middle term, the 6, and cut it in half, 3, and then square it, 9. So this will become 2 times x squared plus 6x plus 9. And I added 18, so I'm going to have to subtract 18 to balance it out. So I had the plus 10, so now I'm minus 18. So I balance it out. That is 2 times x plus 3 squared. Remember, you always use this one there. Minus 8. And it just says put it in vertex form. If we want the vertex, that would be -3, -8. All right, for number 2, first thing we're going to do is factor out the -1 to be able to complete the square. And you can see we kick the plus 3 on the outside there, and then x squared and the 4x become positive. Now I'm going to figure out what to add. That would be take my middle term, 4, cut it in half, 2, square it, gets me back to 4. So I add 4, but that is really like adding -4. So I've got a new -4, so I have to balance that out with a new +4. And so now I'll write it in squared form, which gives me a vertex of -2, 7. All right, for number 3, we are given a vertex and a point and told to write the equation in vertex form. So I want to start with my formula, y equals a times x minus h squared plus k. And I start off with remembering that the vertex is h comma k, so I'm going to plug that in for the h and the k. And so I get y equals a times x minus -1, which means it's really x plus 1, and then squared plus k. K is -5, so that will be -5. Now that I've got the vertex in there, we can see I still just need to find a, and that's where the other point comes in, and I'll plug that in for x and y to help me solve for a. So y is -37 equals a times x plus 1 squared minus 5, except the x, I should plug in that x coordinate from the point, which is 3. Right, there's the x and the y, plug those in for x and y. And now I just go through and solve for a. So let's see, this is -37 equals a times, that would be 3 plus 1 is 4 squared minus 5. -37 equals, that's 16a. 4 squared is 16, so 16a minus 5. We'll add 5 to both sides. -32 equals 16a. And if you divide by 16, we see that a equals -2. And so now I know that I can plug that back in up there. And so my final answer will be y equals -2 x plus 1 squared minus 5. Number 4 is similar. I can see in the graph what the vertex is, 2, -8. I also can see a different point, 4, 3. And so I get that same type of problem as number 3. So I'm going to work through that. So that gets me y equals 11 over 4 times x minus 2 squared minus 8. All right, 5 asks us to find the vital information and graph it. So what I'm going to do is what we saw a lot in the binder. First, I'll write it in vertex form to help me find the vertex. Then I'll write it in factored form to help me find the x-intercepts. So vertex form would be f of x equals, I factor the 2 out, x squared plus 8x plus 14 on the outside, 8, 4, 16, so this will be plus 16, and I've added 32, so I'm going to subtract 32. That gets me equals 2 times x plus 4 squared minus 28, 18, minus 18. Yeah, minus 18. And so then I can see my vertex here is negative 4, negative 18. And my x-intercepts I don't have yet, but my x is a symmetry, is x equals negative 4. So then for my x-intercepts, we're going to factor. So I'm going to write it in factored form instead. F of x equals, factor out the GCF of 2, x squared plus 8x plus 7, and then x and x, 7 and 1, which gives me, if I set it equal to 0, I get, that's my 2, x equals negative 7 and x equals negative 1 are my x-intercepts, so that would be the points negative 7, 0, and negative 1, 0. Domain we know is always negative infinity to infinity. Range I'll put after I graph it. Y-intercept, remember that means find f of 0. Plug in 0, and if you go to standard form at the beginning, we can see that's 2x squared, 2, 0, 0, plus 16 times 0 is 0, plus 14. So I know my y-intercept is 0, 14. And now I can graph it all. It looks like I will have a y-intercept of 14. I will have my x-intercepts at negative 1 and negative 7. And my vertex is negative 4, negative 18. It is off the graph a little bit. And my axis of symmetry is all the way down that negative 4 line, which means I can get from the y-intercept, I'm 4 away to the right, so I can go 1, 2, 3, 4 away to the left. And there's my graph. Not bad. And now I can see my range is from that bottom up, negative 18 to infinity. For 6 and 7 here on the back, I'm going to have it just kind of speed through, but so you can kind of see what the work I'm doing is. Just to point a couple things out quickly, in 6 I got the vertex, and then in the y-intercept pretty easily. I look at this and I tried it, I couldn't factor it, so instead I just picked another point and I said, well, what's my y value going to be when x equals 1? I know I had these two from the symmetry, so I just needed to pick f of 1, found out that was a negative 3, and then got a symmetric point there. For 7, similar thing, I got my vertex, tried the y-intercept, but it was not useful for this graph because it was so low. So then I just said, well, I'm at negative 4, might as well pick negative 3 and x equals negative 3, x equals negative 2, plug in and see what I get for my y value. And that was was able to get some symmetric points over there. If you solve this for 0 equals, you could get an x-intercept, but the numbers won't be very nice. All right, quick look at number 8 here. Throwing a can to the recycling bin, modeled by the function negative t squared plus 2t plus 3. A is what time does it reach its maximum height? That should make you think vertex. So let's do the x equals negative b version because we haven't done that yet. Negative b over 2a. So 2 is b, so that'd be negative 2 over 2 times negative 1. That's negative 2 over negative 2. So that's 1. The x coordinate is 1. And so then I do f of 1, or the t coordinate I should say, is negative 1 with the negative on the outside, plus 2 times 1 plus 3. That's negative 1 plus 2 plus 3. That's 4. So, so part A is at what time? And that would be at t equals 1 second. And then I actually answered part B there. The maximum height is 4. So 4 feet. F of 1 equals 4 feet. C, when does the can hit the bottom of the empty recycling bin? That would be height equals 0. Or f of t equals 0. So we go 0 equals negative t squared plus 2t plus 3. I could factor the negative 1 out. I could do quadratic formula. I'll factor the negative 1 out. So that's negative t squared minus 2t minus 3. And that's negative tt. It's got to be 3 and 1. I got to add a negative 2 in the middle, so minus 3 plus 1. So I get t equals 3 or t equals negative 1, but that can't be right. It can't be a negative time, so after 3 seconds. Number 9, same idea, but we would do it on the calculator. You could find the max. You could use the solver. Let's put the graph up. Alright, so I got a video here. We're about to graph it. And what you can see is when you graph it, we need to do a few different things. If we want to find the maximum, we can do analyze graph maximum and then slide it to the right. Make sure you get, so you can see there, and it was there, so we need to get the maximum there. That's going to be my maximum height at what time and what is, so the time would be 4.59 seconds. And then if we want to find the x-intercept, we do that analyze graph again and then click 0, and we want to find the one that's to the right there, so kind of tight quarters there, but we have that. So now I can see from that video our x-intercept is when the drone will hit the ground, and that would be after 9.85 seconds. Okay, when does it reach its maximum height? That's our vertex, so after 4.59 seconds. And then what is the maximum height? 135 meters. And then how high will the drone be at 1.25 seconds? That's where we could do graph trace, or we can type in our calculator negative 4.9 times 1.25 squared plus 45 times 1.25 plus 32. And you get 80.6 meters. All right, hopefully that was helpful.